Okay, totally bashed ICOM IC-725. eBay special. Obviously picked it up quite cheap. The seller basically said it was damaged during transit, so he probably bought it, or something's happened, or he sent it to somebody and it's come back because it's not been packed properly. It looks like it's landed on its nose onto the rototorculator VFO. But yeah, she's in pretty bad shape. And if we take a little bit of a squeeze, you can actually see, look, the LCD's broken, which is a bit of a problem because these things are obviously bespoke. They're actually made. There'll be a production run made for these. ICOM probably didn't make them, and there's only so many made, you know, because they're not a generic part, as with quite a few parts within this. But we'll go through that. But we need to assess what the level of damage is. I want to see if we can resurrect this thing, get it possibly, you know, if I can turn it back into a working radio. But it's looking rather bad considering the condition. There's a bit of history behind these. It's the IC-725. I think it came about 1988, and they were phased out in the sort of early to mid 90s. They're actually got a really sensitive receiver on this. They have got a good receive. The only problem is I think they're a bit wide. So a bit wide, and AM/FM does not come as standard. It's an extra board. I don't know whether it's fitted in here. I've not had it apart, so I've not powered it up or anything. So, but they're quite sparse on features. They don't have, which I like, an RF gain. There isn't one. You've got a attenuator here, and you've got a preamp, AGC noise blanket. You've got the usual suspects. It's got an A and a B VFO. Obviously, you can only receive on one at a time because of how it's designed. But yeah, so you've got all the usual good stuff, and we've got a little RITI there, receive increment tuning. But that's it. There's nothing remarkable about it. So you might say, well, why is it worth trying to fix something like this? Well, you'd be surprised. They're actually quite good, and they're built like tanks, these things. And to be honest, they're actually quite a reliable transceiver. There was a lot of these made, and over the years I've serviced. I've had them in, but not that many, and I know there's a lot out there. But it's normally through people messing about with them. I mean, I had a look at this, and we can have a look here. The screws don't look too monkeyfied, so it's all about if someone's been inside messing about with them. You can do the Mars mods on them and all that rest to carry on. But ultimately, people, it's best just to leave them alone. Leave them to the experts. But look, that is bashed in. That is pretty bad. That's as tight as you like. It doesn't feel buckled though. So the rotary encoder is probably okay. So, but I'm concerned because behind here there's a panel. There's a circuit board, and I just want to see the extent of the damage on there. Obviously, as we said, the display's totally shot. You never know. We might be able to get. It might be showing something up here, but yeah, she's in a pretty bad way. Okay, the back here, pretty standard stuff, really. Obviously, antenna socket. We've got a extension speaker. We've got, this is a CW break-in, and that's the delay time for it. We've got a 1/4" jack for a key. We've got 2 accessory sockets there. They're the old audio type connectors. Are they not DIN connectors? I can't remember what you call them. We've got an ALC input here, which is obviously for a linear. And with this one, it's called Send, which is, I think that's just a PTT. So when you key the mic, that will just go low. And then we've got the CIV data. It's just serial information. means we can, I imagine you should be able to control the radio, and we'll be able to interrogate the radio as to what the settings are, or, you know, current settings. So I may have to use this. I'm not sure how well this is going to work. Obviously the microcontroller in this is pretty primitive. So I don't know what the speed is. We'll cross that bridge when we get to it. Okay, well, let's get it apart, and we'll see the extent of the damage. Okay, well, this is the underside. This is the main unit. And as Dave Jones says, you Bobby Dazzler, I think we've really locked in here. We've got an AM FM board. That's an option. So I'd say that was, you know, so somebody's obviously spent some money on this thing. And we've got our sideband filter. This one is an FL30, which is, if I think that's right, if we zoom in, I think that's 2.3 kilohertz. So yeah, because these, as I said, these things normally have a 3 kilohertz crystal filter in there, and this one's got a 2.3, so that's not standard. And if we go look here, we've got that's a carrier wave, you know, crystal filter. So yeah, and I think that's, what's that, 250 hertz. But yeah, the actual frequency, center frequency of these is just below 9 megs. These are a dual conversion super heterodyne receiver. I think the first IF's, I think it's just a tad over 70 megs, then it drops down. The reason they do that, obviously, you know, it's to do with the design and the coverage. You've got your bandwidth, your filters here. If they're too, depending on the width of the filters, if you're not careful in your RF design, you start to get overlap on your, you know, in your mixers. So, you know, you start to see stations that are not there. It's like images lying on top of images. So yeah, no, it gets a bit complicated. But the board's in really good condition. That's the main unit. Obviously, I'm still going to have a look at the front. Okay, now this is the PLL board, which is, well, we've got the radio the right way up now. Obviously, this is the RF section at the back here. You can only just see it. But if you have a look at it, it's all looking good. It looks like, I think these are the diodes here. I can't remember, but if we just zoom in, I think they're the ones that get attacked, because I think it just gives you, so you can actually transmit out of the amateur radio bands. Let's see if I can get that in a bit better. But if you just zoom in there, I think it's this set here. And they actually look all right. They look like there's nothing been changed. There's more diodes. If we just zoom back here, if we have a look down here, yeah, we've got more diodes. Everything seems all intact. Now, I haven't looked at the underside of these boards, but yeah, no, it all looks good. It looks promising, which is nice, because you know, there's nothing worse than getting monkey-fied rigs. You know, and as I say, you know, your normal, the way you tell, it's got all the screws have had the heads all torn off because they've been on and off that many times. It's just people tinkering about with them. So, you know, they initially put a fault on them, and then they're constantly taking it apart, they're chasing their tail, basically. Normally happens, you know, people just sit there and think, oh, well, I'll do a bit of give it an adjustment, and then knock something else out, and then they go back in and sort that out, and then knock something else out, you know, and do it with the proper test equipment. Anyway, I'll stop whinging, but if you actually look here, we've got, that's in the docs it says it's a CPU, but it's, well, I suppose it is, but it's a microcontroller unit, so it's complete. It's got a CPU, there's some memory in there, obviously there's RAM, there's also, I would imagine it's E2 PROM built into it. It's an 8-bit unit, quite primitive. It's quite functional though. It does exactly what, you know, it needs to do for the radio. And obviously these diodes at the top here, these literally just connect onto pins, and as it's going through its program, if it knows that these are out, or whatever configuration they're in, it'll behave in a certain way. So it's just how it's programmed. Again, this is a bespoke part, even though that you can buy the microcontroller. The reason it's a bespoke part is because it's got the program that ICOM have written, and it's obviously been compiled into a hex file or firmware, and that's actually been uploaded into it. You know, the only way, you know, there's no point buying one of these ICs if it's gone, because it simply won't work, you know, because it won't have the program in it. The only way is actually programming. There's two ways to do it. You either have the actual hex file, or you actually have the source code, which would be even better. But I think it's unicorns if you think you're ever going to get hold of that. You never know. Yeah, if you got the source code, you can actually make some changes to it and obviously compile it, and you know, load your own firmware in there. But there it is. But one option is, I'm not sure, but I have to check. But if you've got one of these gone, just somebody take one out, put it on a reader, and see if you can dump the hex file out of it. I know there are protections that can be put on these to stop people doing that, but I don't know what extent they've gone to, whether it can be done or not. I'm not that experienced with these type. You know, I've never programmed any of these. All the stuff I've done is at Mega, you know, Arduino type stuff, which is a totally different beastie. So. All right, well, let's get the front off. Let's have a look, and we'll see what's occurring, see if we've got any damage to that panel. But I've initially had a quick look under there, and it's not looking too bad. Okay, so I've got the front panel removed. There's a lot of wires. I just hope I remember, you know, whether you'll go back. I'm sure I'll sort it out. Okay, so it's not good news. Let's have a look here. I don't know if you can see that. Let's see if we can zoom in a bit. Oh, that's bashed in. I don't know if you can see that, but the board, circuit board, is bulged. I mean, that is bulging. Can you see that? Yeah, let's see if I can get it a better angle. But it's actually bulging. Yeah, you can probably see it there. We've got a bulge and we've got a crack that's running right away along here. So I think, and it's obviously it's cracked around that screw socket. Now there's not a lot on this board. I think it's just mainly switches. There's a little IC here. This is a little NEC device. Basically what it does is just takes serial information from the microcontroller in packets. There's various ways to program these, and it's basically an LCD driver. So I think that's programmable. So again, that would be, I don't know whether it's programmable externally or the microcontroller actually programs it on it when it starts. I'm not sure, but that'll run the LCD sort of, you know, membrane that it's that's printed on there, so it'll work in a certain way. But that is pretty here, you know, over here. That is pretty mangled. So I mean, I think this is only single-sided board. That I think is, yeah, that's that's our rotary encoder. That's a small one, isn't it? So, yeah, I don't know. Let's take this board off. Let's just zoom out a bit. So if I see if I can remove this whole section here, then we can have a look. And these cracks, if I can straighten the plate at the back and get everything sitting in correctly again, I could most probably patch these up, because it doesn't look too bad. And I don't think, you know, we're not dealing with RF or anything, so I think it probably we might be able to do that. I don't want to spend too much time on it, obviously, but okay, let's get this board out and dig a bit deeper. Okay. I'm having some fun here, I can tell you that for nothing. Yeah, this is it's coming apart. We're getting there. I'm going to solder on. These are blocking the, and I'm going to get this for the headphone jack, because that is going across the board here. She's stopping this board coming out. Bit of a crazy design, a lot of wires, but that moving swiftly along. Okay, and finally I got it out. Now I'm actually holding the camera, so I'll try not to shake, because you're going to get motion sickness. Okay, so we got the thing out. It's pretty, yeah, look at the focus. Yeah, it's pretty bad. You can see there's cracks here. Can we see if we can get this bastard thing to focus? Hang on. Focus on the pencil. Okay. Yeah, but it came out. Obviously the screen, you know, the display is completely shot. That's you know, that's never gonna come back. The section here might just that might just work. You know, just, and I think that's where the frequency is. So it could possibly make it usable. But I'd like to see if we can get it going. Then we can look at some options, because we could probably put something in place of this screen. It's an option. I could program something up, write it in C++, as long as I know, obviously, if I can interpret the information that's heading up to that IC on the other side. That would be the trick. But, I mean, it's all speculation. I don't know whether this thing's going to come up. So if we look on the underside, I'll kind of straighten the thing out a bit. I don't think you can see this, but it's, yeah, there's some cracks on there. Now, one quick word of advice, I don't really like giving advice, but this is you know, we all learn the hard way. If you've got crack boards, this is okay, because this is a single-sided board, so there's only tracks on one side of the board here. There's no tracks on the other. It looks like there's tracks, but they're just tracers telling you where the tracks are. So these are just tracers. They're just saying, look, which is quite handy if you're servicing. It's a good thing, you know. So one thing to avoid is that if you see a crack, it's like here, for instance, if I can, come on, hold straight. Right, let's try it there. Okay. So if we've got a section like here, it's cracked. I don't know whether you can see it, but there's a crack there. So, it's a temptation just to scrape the lacquer, the screen mask off the printed circuit board and put some solder over, and it probably would take. But the problem is, as soon as that board flexes, which it will when you screw it back in, it'll break again. So what you have to do is actually tie fine, wires from the points that bridge the gap. So that's the way to do it. That's the only way you're going to do it. And it means that if it does flex, it it gives you it gives you a little bit of wriggle room. So it's not going to it's not going to stop the show. But even if you see a crack, let's have a look. We got one here. Look. There's a crack coming up here. So what you want to do is imaginary things, try and work out where that crack's going to go. And even though the ones are intact, do those as well. Make sure you do those as well. So if the crack goes up, it'll still keep working. It's not ideal. It's all a bit, Heath Robinson, but it's the only way you're going to get the thing to working. Now, I like fiddling around with radios. If this was a repair, if somebody brought this into me as repair, I would refuse it. It's as simple as that. I'd just say, look, because I can't, you can't guarantee your work. It's because it's too far gone. I don't know if you watched Shango 66, but it's gone quinkedinkler. It's certainly, gone too far. But you know, for the interest of making this video, I reckon we should have a crack at it. You know, I was thinking to myself, oh, should I do it or should I just stop it here? But let's do it. Let's go. Let's see what we've got. Let's see if we can get it to go.